Alright guys, welcome to Period 7 Math. We're going to be learning about the domain and range of functions. Miss Legs is going to go up to the front. Let's go.
Let's do this. I got my little intro. I'll give you one because next week. Okay.
Thank you.
You're welcome. Not everybody did. Who got Jolly Ranchers? The people who had their notebook out and were quiet and ready to go. That's okay. Let me really quick take attendance. Everybody seems to be here. Is that right?
Hold on, let me check.
I will be soon.
Some parts are. So, now remember though, you need to be like calm and really engaged in what we're doing, okay?
Yeah.
Random.
Okay guys, a couple of things before we get started with the lesson. Are you okay? Try to move or like in a way that does not bump into it. It's okay.
I didn't see
You
it.
can still see the
You didn't
whiteboard.
see it?
I'm blind.
He's visually
Okay.
impaired.
Look at me, please. Thank you. All right, we do have a big lesson today, but it's the first day of second quarter.
It is?
It's the first day of second quarter. We kind of started this topic before the weekend because we went over the topic readiness test on Thursday and Friday. Then you had a 4-day weekend, so you probably forgot most of it. That's okay. We were still preparing and getting ready to start this. Yeah.
I think the videos you told us a lot.
Oh, good. Did you feel like they helped a little bit? Like, no?
I already knew that basic stuff, but then when there's other things that we want to
Okay. Okay. So, we did have a long weekend, so our brains kind of probably got a little bit fuzzy, and we need to really refocus. But what I want to say before we go into the lesson today is a lot of you were having some trouble getting assignments in on time last quarter, okay? Some of you were on top of it. Every day you got your assignment. Some of you, maybe one assignment was a little bit late and you got it taken care of, no big deal. But a lot of you really struggle with getting assignments in on time or at all. I had a lot of you emailing me up till like the day that I was doing grades saying, I finished this assignment, and it was from like weeks before. Guys, we can't be acting like that, okay? We need to be handling our assignments on time, okay? That is my expectation of you. That was quarter one, where we were still getting to know each other. And now that I know you guys struggle with doing your assignments on time, I'm gonna be more kind of like on top of you guys about it, communicating with parents when things don't get turned in on time. Why is it so important to turn it in on time? Yes. Yeah, not just, but it's not, you're right, because the grade gets reduced, but what else?
Also, you don't learn that skill until you do it.
Exactly. You only learn so much during class. Then you leave and it's just like, huh? You need to practice it that night to reinforce what we learned, or else you're not going to be ready for the test. Math is very hard to study for. It's not like you can cram the night before. The way you study for a math test is you practice it each and every day with whatever homework is assigned. Yes?
So, all the work builds up.
Yes, all the work builds up and then you're stressed out at the end. It's like, how can I bring up my grade? All this stuff, and it's very sad. So let's make a little vow, give me a little head nod. If you are committing to getting your assignments, your assignments in on time. If I could get a head nod. Good. Okay, because I need a head nod. If you agree to get you never had problem with your assignments, just not anyway.
No, that's such a lie. Yes, I did.
You did?
Yes.
Oh, really?
I'm sorry.
Just once or twice?
I promise.
I have no idea.
For the most part, you do.
I was pretty good. I guess.
Mhm.
I mean, like, I studied.
Yeah, but you guys you guys know who you are. The people who are having trouble getting them in on time, you need to make a change. New quarter, new you. Okay? Oh, I came up with a new thing.
Quarter resolutions.
I came up with a new slogan for quarter 2. Remember it used to be I scare because I care?
Oh no.
Now it's I scare you to prepare you. Right?
Oh yeah, that's a good house.
Ow! Oh my god!
It's like
Okay. Okay, now listen. With that being said, I really want you guys to take that seriously, okay? You know that I'm doing everything I can to teach you. I know some of the stuff is tough. I'll slow it down when I need to. But if I'm slowing things down and you guys aren't handing in your assignments, it can't work like that, okay? That's not balanced. So as long as you guys are working and showing me, hey, I'm doing everything that I can do, but I'm still not getting it, that's when I know I need to slow down. But if I'm slowing down and you're not handing in your assignments, it's like, well, what am I slowing down for? You're just not even doing what you're supposed to do. Now, I also did a training yesterday with a representative from this company that wrote the book, and it was really good. And I'm gonna try out a little bit of a different 2-day lesson structure. It will pretty much be the same, but a little bit different. So, you know how I taught a lesson over 2 days?
Yeah.
Yeah. It's still gonna be like that, except the first day, I'm gonna try to teach the whole lesson and all the examples. So far, I have not been successful today because a lot of people are like, I still don't get it, so I go over it again, and we actually didn't finish the lesson. I am really gonna try, because I'm recording this one, I'm really gonna try to get through the whole thing. If I can't, that's okay, and we'll adjust. But I really wanna get through the whole thing today, and then you guys are able to do all of your homework tonight. Guess how many homework problems I assigned you?
1.
6.
What?
6.
26.
what are they hard?
Remember in elementary school when you got 30 problems a night?
Oh yeah, we don't have 50.
How are you guys talking? It was a yes or no question. Do you remember that?
Yes.
Yeah. We could do that. I could give you 30 problems, or I could give you 6. How's 6? Okay. But they range from range. They range from easy to challenging. Like the last 2 are on the challenging side. But I scare you to prepare you. We have to get prepared for the end of course exam. Some of the questions are on the easy side and some of them are very, very challenging. So I just want to prepare you to be able to answer any question that you see, okay? It doesn't mean you have to be able to get all of them right. It just means I want to prepare you for that, yes.
So,
Yes and no.
so if we don't know like the super challenging ones, is it gonna be like, and you are gonna go over the examples the next day? Could we wait until?
Yes, that's a good question. I'm okay with that.
Like
Yes,
you're not gonna kind of wait?
correct.
Okay.
That's a really good
Do you want us
question.
to email you that? Like,
No, I'll just say, we'll just keep it a 2-day due date.
Wait, what is it?
Okay.
So she asked a question. She said, if you're assigning it that day and teaching the whole lesson, but we get to a challenging one and we really need help on it, can we not submit the assignment yet and get help on it the next day and not be counted late? Absolutely, I love that idea. No, and she asked that too. I actually don't, you need to email me. I'll give a 2-day due date for all the assignments anyway, since technically the lesson is over 2 days. But does that mean you don't have to do it at all the first night? You want to do as much as you possibly can, then I will, oh, you know what? The only tricky part is I'm supposed to go by the data. I need to go by the data of the submissions. That's the only tricky.
Just skip it and then you'll unsubmit
Let
it.
me think about that. For this time, go ahead and make it a 2-day due date so you don't have to submit it tonight. Let me think on that because,
You don't.
yeah, let's just keep it a 2-day due date. I know which problems are more challenging and which ones aren't, so I'll just go over like the challenging ones. Yeah, so a 2-day due date, and then what else? So day 2 of the lesson, the goal is to do all of the examples on day 1, which we might not get to, we'll see. Day 2 is going to be going over 1 or 2 of the homework questions. then taking a quick 5-question open note quiz on the lesson. Will the quiz count? That depends. If you guys are doing your homework on time and trying really hard and you're still bombing the tests or quizzes, I'm not gonna count that certain quiz because that's a reflection on me, not on you, okay? But if I'm teaching my little caboose off and you're not doing your work and then you bomb the quiz, that might go ahead and count because that's not fair that you're not doing the work and then don't want the quiz to count because you bombed it. Does that make sense? Oh, no. They can hear this too. Just fast forward through it. So,
Hello, viewers.
I think that was it. You have a question? Yeah.
Can you already believe it's quarter two? We're halfway.
That's not helpful because I have a whole lesson to get through today. Okay. Yes.
When you interviewed the people for this book,
I didn't interview them.
oh, not interview them, but like you saw them, you said, right?
That'd be
Like
so
you saw
funny,
somebody.
just like,
Yes, they know about the
why
mistakes.
is there
Okay.
Yeah.
spelling error?
That's somebody else that I yeah. Okay. It's okay. All right, can you sit up one? So with that being said, let's go ahead and start this lesson. The homework tonight is 6 questions. Try to do as much as you can. I will also post the video, okay? Yes. Yeah.
So tonight the homework 6 question and tomorrow we also get 6 question homework, or is it like work on it
No,
tonight and work on it
I'm gonna
tomorrow?
give you an activity tomorrow and whatever you don't finish will be for homework. So just for tonight, just worry about tonight at 6 questions. Try to do all of them, okay?
I got 5 hours of sleep.
Okay. So today we are talking about domain and range. We talked about this a lot last week on Thursday and Friday. What does the domain represent?
I thought you were talking about training. I really don't know what it is.
The domain is input
The input, yep.
and
And the range is
output.
output, good. In terms of our coordinate pairs, yes, Angelina,
Domain is X and range is Y.
good. The domain is X and the range is Y. And that never changes. That is something that we have to just memorize, that these 3 are the same thing. The domain is the same thing as the input, is the same thing as the X value. The range is the same thing as the output, is the same thing as the Y value. We use them kind of interchangeably depending on the situation. Can you sit up? Okay, so today we are just talking about how to describe or notate the domain and range. What does notate mean, or what is a notation? Yeah.
That's the way that something is written.
Yeah, the way something is written. So how can you use notation, which is the way it's written? How can you use the notation, the way that it's written, to describe the domain and range of a function? So we're going to write a description of the X values and our Y values. Now, if I just put like a single coordinate point on a graph, like let's say I put a point here, and I said, what is the domain of that point? What would you tell me? If I just asked what the domain of that point was? 3. Very good. Is there more than one option for that, or is there
Yes.
one single domain for that point?
Just one.
Just one, because it's a single point. But if you have a group of points that are so close together that they actually make a line, right? Then you have a lot of X values, a lot of domain
That- that
values. Just depending on where your point is on that line, it's gonna change, right? Yes.
Number.
Okay, so in order to describe what the domain could be, we want to describe all of the values that x could be on this line. And the easy way to write it is to simply, just hold on 1 second, is to simply find out the distance on your x-axis between these 2 points. Something else that is a little bit different on this coordinate plane is we're used to seeing lines that have arrows and they continue to like positive infinity, negative infinity, or whatever it is.
Yeah.
But here we have endpoints. So there is a limit to our x values. If we had a line that, let's say, like went like that and continued in both directions, can you guys see that?
Yes.
If I had a line, I would just say x, because if it continued all the way to positive infinity and all the way to negative infinity, depending whatever point it is, we would just say x would be all real numbers, because it would just continue all the way in both ways. Here, it has limits, okay? Faith, can you sit up, wake up? Yeah.
So, like, would there ever be a problem where it's like, you have that line, but they want it to be like a line that's limited?
If it is, it would either show that it's limited or something in the like word problem or real life situation would give it some sort of limit. For example, she wants to make more than $10 at the book sale. So that limit would start at $10, but it would include $10, it would go above 10. So there would be like an end
So like a ray?
there.
That'd be a
Yeah,
ray.
exactly. Okay, so now that we can see there's a starting point and an ending point, but since we have to deal with the x values and the y values separately. So even though this line goes like, woo, there's a slope, we don't really care about slope right now. When we're talking about domain and range, the slope doesn't really matter. We're simply saying, how far can you go on the x-axis according to this line? It doesn't matter how far up and down it goes right now. We're just doing the x values. So on your x-axis, if you kind of like line it up, it has to start at -2. And you'll notice that the starting point here has -2 as the x value.
How do we know what we solved it before? Because you said we're trying to solve for just x. Wow.
Well, we're not solving for x, we are identifying all of the values for x. And we know that because if it asks you, what is the domain?
It says in the range.
Right, but so we're answering it in 2 parts. So what I'm saying is, since we have to answer 2 completely different questions, we'll answer the domain first, then when we're done, we'll answer the range, okay?
Does it matter which order you go in? Can you do like the range is blah 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 and the domain?
Like if you had a question on a test or something or on the EOC, it would say what are the domain and range of this function, and then it would give you like 2 separate parts of it. The domain is blah blah blah, the range
Or
is
the-
blah blah blah.
Well, I'm saying like if it was written and you didn't have that text box.
You would know it, you would be able to write it by identifying the variable x, and that would indicate that you are finding the domain by using the variable x. Okay, because the variable y would indicate range, right? So that's how we could separate it like that. Now, again, so we have this starting point here at -2 on the x, and it goes all the way to here, which is +4 on the x. Can it include the -2 and the 4 as well? I know it includes all of these numbers in between. Does it also include the -2 and
Yeah.
the positive 4? Yeah, how do we know? Yeah.
Because it's on the same line and it's kind of highlighted. So it's like, basically if you go from,
There's something about the way
The
that
limit.
line is, there's something about the way that line is drawn that tells us that we have to include the -2 and the 4
Because
in
it
our domain.
goes from the lowest to the highest, and those are the only 2 numbers that are the lowest and the highest.
Nope.
It's uneven on both sides, so it says -2, and that then it says 4, so it's like,
Nope.
it ends.
What do you notice about those little endpoints?
That it ends right on them.
They're they're continuous.
It ends in like dots at the end.
What kind of dots?
Filled in.
They're filled in. Very good. They are filled in dots. Just like when we've been working with inequalities before, if it's filled in, it's included. And that's why when we write our domain, we're saying that x is in between -2 and 4, inclusive. Remember the word inclusive? Inclusive means it can be anything between these or including these. And this or equal to sign is what indicates that it is inclusive when we write it out. Does that make sense? Willie, are you getting any of this down? Okay. So we write the domain for this as -2 is less than or equal to x, and x is less than or equal to 4. The way that I read that for my own brain, for me to understand it, is I read it as x is in between these two numbers, including it. So all of the numbers from -2 to 4, including
Oh, bless you.
3.96257, right? Because that's somewhere in between, right? So we're including all the real numbers in between those. Yeah.
So since your domain is x, so it'd be -2 and 4, and then if it was y, then it'd be and -3.
Yeah, we're getting to the range next.
So we're doing for these like greater than or equal to lines under them too.
Yep. If the dots are closed circles, then it includes the values. We're gonna see in the triad example, something that's a little different. Yeah.
Does it matter the order that they go in for domain and range? Does it have to be -2 like that and then 4, or can it be like?
Yeah,
As
it has to be in order from least to greatest. Charlotte?
Does it mean anything if it's an open circle?
Yes, we'll talk about that in the triad. So think of what it would be if the closed circle means we're including these and we need the or equal to sign. Think of what it would look like if we had an open circle.
Non-inclusive.
Yeah, it would not be inclusive, and so we wouldn't have the or equal to sign. It would just be -2 is less than x is less than 4. If this was an open circle and that was an open circle, so then we would have basically this. But that's not the case here. We'll have that case in the triad. Okay, let's look at the range. The range, remember, is measuring, careful of the tripod, is measuring how far it goes up and down. The range of numbers, okay? Yes, you wanna say it? Yes, the range is the output. And on here, when we're looking at the graph, we see the very bottom that this line goes is -3 on the y, right? You see your y value for this coordinate is -3. That's the starting point of the range, -3. And y is anything from -3 all the way up to 5. So the y values, or our range, is in between -3 and 5, inclusive. Closed dots, inclusive. So this is actually all, again, just like the domain, all real numbers are included in this, because this continuous line, which we'll talk about continuous in a little bit, continuous meaning it's not just the whole numbers, it's not just negative, or it's not just the integers, -3, -2, -1, 0, +1, 2, 3, 4, and 5. It's talking about -2.6, 7, 8, 9, 10. Wait, no, you can't have 10 after the decimal, that doesn't make any sense. -6, 7, 8, -2.6, 7, 8, 9, 9, 2, 5, 6, 2.
That's crazy.
All of those real numbers.
I'm very confused.
Yes.
Does it matter which way we put them? So could it be like 5 instead if we like switch them?
Technically,
Or
if you wrote this way, 5 is greater than or equal to y, which is greater than or equal to -3.
Oh, I'm sorry.
This is technically the same thing, but it would not be the correct way to notate it. Just like if I said, arrange these numbers in order from least to greatest, and you're like, well, can I make them from greatest to least? It's like, well, yeah, if it asks for greatest to least. So
So usually we're asked
Yeah, but when you notate or write the domain and range, you're going from least to greatest. Okay, I feel like you guys are getting this and I'm excited.
Is it always?
It's very hard to.
So that was writing the domain and range as inequalities. The great news about this other way to write it is it's exactly the same, except in brackets, okay? It's called something totally different. This way was writing it as inequalities. And just saying the domain is this inequality. This way, we're gonna write it the exact same thing. Look, exact same thing for the domain, but it's very fancy. This notation is called set builder notation. So you can write that down, set builder notation. It basically is using that same inequality, but first opening up some brackets, using the variable to indicate what specific variable you're going to talk about, then separating it with a very fancy vertical line, and then simply writing the inequality that we just wrote and closing up the brackets. That's all set.
Does it have to be the little squiggly ones, or can it just be like the parentheses?
Parentheses, if all you can do is do parentheses, that's totally fine with me. Because you have a squiggly bracket key on your computer,
Thank
or,
you.
yeah, for that.
I deeply appreciate it.
And also, like, on your homework and stuff, it's, the brackets are done for you, you just fill in.
I was about to say, like, if we don't put the parentheses, will we, like, let's say that we just put normal parentheses, like, will that be wrong if we?
Yes, but for now, it's done for you. We'll see if we get to the point where you'll have to put in the brackets, okay? So, do you guys see how the numbers, the inequality is exactly the same?
Yeah.
And then, same thing with the range. You just open up some brackets. You indicate which variable you're about to announce. Hear ye, hear ye. This set builder notation is going to announce the range in the form of the coordinate y. Set builder notation, and then I'll make my inequality. And then I will close my brackets.
Can you talk like that for the rest of the lesson?
No, because you guys will be so distracted, I won't get anything done. Okay, shh. And the way that set builder notation is broken down, on the left side we have our variable that we're announcing. I do declare that we will be talking about the x values. So we're kind of declaring our variable, and then we're talking about the conditions of that variable. The conditions simply mean what x is allowed to be. Just like you guys probably have conditions in order to attend the homecoming dance or go out with friends for the weekend. Or not for the weekend, you don't go away for the weekend, but like go out on the weekend. You probably have conditions like as long as all your assignments are up to date, as long as your room's clean, and as long as, I don't know, you took the dog out for his walk every day, then you can go. Those are the conditions. X has conditions too. X can exist only between these two numbers and including them. Y can exist only between these two numbers and including them. Yes?
So why do you only have one line, like, you know, where the X on the left of it, no, right of it, there's a line? Why don't you have another right to the right line?
Like this line?
Yeah.
Because all we're naming is the variable and then the conditions of the variable, and that's all we need. Okay, you guys are gonna try this on your own. Actually, with a partner is fine. It's a little tricky the way they set it up, so I want you guys to wake up. Thank you. And pay attention. I'm gonna give you guys some instructions. Describe the domain and the range of this graph, or this function, using an inequality and then using set builder notation. So, you're going to do the domain and your range as an inequality and as set builder. So it's really a question that has 4 answers. You're gonna do the domain as an inequality and your domain as set builder, which is the exact same thing, except you have to declare the variable first with fancy brackets, and then your range as an inequality and then with set builder.
I think there's a typo in there. 'Cause-
There is a typo, thank you so much, I totally forgot to say that. Thank you for catching that, I've already emailed the company about that. Yeah, we noticed that in first period, so. Angus, yes or no? Did you get any notes down for this lesson? There's no talking unless you are working together on answering this question.
Less than. I told you. I'm probably smart. Oh my gosh.
Okay, I'm done with like.
Okay. You
Do
done?
you look good? Do you look good in that one different way? So you have my fancy line.
Oh, sorry.
My wife, no. The wine or something.
Yep, those look great. Okay. Good job. Yeah. All right.
Yeah. I want to do one. Can I do the next one, Miss Lady?
It's your time to shine.
Can I do the range?
Can you do the domain?
Huh.
Can you do the domain?
Yeah, I want to do the domain.
Oh, okay, go ahead.
So the
Yeah, I'm trying to
I have to get into my teachers.
Yeah, get into the teacher position. Hey guys, Grayson is gonna do the domain, and then Part-Mine will do the range.
No.
I think the phone's ringing.
That's me.
Sorry.
Sure, he was just about to do something on the board. Can it wait like 30 seconds?
No, me.
Thanks. Bye.
That's me.
No, him. You keep going. You can go after you have.
You gotta go fast, Grayson.
You're making me stress, Carmine.
Too bad.
We're not chatting. We're paying attention.
Oh, man. Just a little.
Yeah, that's okay. Good.
There you go, Carmine.
All right.
Oh, we don't include it.
It's your time to shine.
Oh, we don't include X on that one? Oh, no.
No, she was just saying it's not inclusive in the inequality.
Is that a 1?
Yes, that's one.
No, it's not.
No, it's
Good. Oh, wait, there's only one problem. You're indicating the wrong variable, silly.
I know.
It's the range, so it's
You
fine.
silly.
You know what I meant.
It's okay, just silly mistakes. You have to declare that it is the y. Why? Remember? Remember why? Girls, are you getting this?
I understand it. What?
Good. I'll take that. Now you can go.
Adios.
Oh, you forgot to close your brackets. That's okay. All right, you guys.
What is the, so right on the
many times do I have to speak to you until you stop talking? Okay, so the domain, again, remember the inequality is gonna be exactly the same in your set builder. So here we have, the domain is negative between -1 and +3, but it's not equal to it, it's not including because we have the open circles, okay? To answer your question from before, Charlotte, you understand that the open circles, we do not include the equal to sign, the or equal to part, okay? And then the set builder is the same inequality, just indicating the variable first and then the conditions of that variable. And then the range is our y, so we have a range from -1 down here to +1 up here, open circles, so it's not inclusive, and then we just declare, what?
They look like Kermit's eyes.
Yeah, they do. Then we're declaring that we're talking about the y, and then we give the conditions of the y, just like the inequality. Are we good? Okay,
Miss Leg,
yeah,
can I say something?
sure.
You have no idea, like, you had no idea.
Oh, I probably would not have noticed that until class was over and I went to put the cap back on.
What?
Caffeine.
Because
I love
I
that.
like,
I'm gonna be honest with you guys, I will probably be able to get through this example and that's probably it, because it's a big example. And then the last one, you guys have access to this at home. It walks you through the entire thing. So you guys can look at this at home to work on your homework. But since we're not gonna finish this whole thing, again, I'm not collecting it for a grade tomorrow, but on Friday, the homework will officially be due. Okay, does that make sense?
I have an idea.
Hold on, save it for later.
Oh my bad.
So, tomorrow, if we have any questions, can we ask you?
Yeah.
I was gonna say, like, you should start, like, you should like posting all of these, like, slides on Canvas.
I post them every
Oh, I
single
don't
time.
see them.
It's called the Interactive Student Edition.
That's what those are.
Yes, and you can even like type in your answers and it will like say if you're right or wrong. And it's not for a grade, you can just do it to practice. Like for the try-its, like this, like in the Interactive Student Edition, it'll have a box where you can actually type in your
Oh, I thought that
answer.
those were just like random assignments for other classes that you accidentally posted.
There's a stranger at the door.
That's it. We'll let it.
Here.
Okay, give me about 7 more minutes to get through this. You guys are doing well with this so far. I can't have all the little noises that I'm hearing, okay? Now we're going to analyze the conditions of domains and ranges based on information that we're given. Instead of looking at a graph, we're gonna get some information and then decide what the domain and range could be. It's a little bit trickier when you're just going off of information because you're not like seeing the visual stop and start of things, but you'll see on the next part where they actually do graph it out and you can see it a little bit clearer. But let's take it step by step, okay? So I need your pencil in your hand, Angus.
I got a pen in my hand.
A function can model each of these situations, which we will see. On the next slide, we will see the graphs. But let's just read about these situations and try to talk about and identify what the domain would be that would make sense and the range. Situation 1. A hose fills a 10,000-gallon swimming pool
That's a lot.
at a rate of 10 gallons per minute, okay? Now, a reasonable domain in terms of the time that is passing, okay, because we're dealing with two things. We're dealing with how many gallons it's being filled up and the time that's passing. Eyes open, everybody awake and alert, okay? If we're dealing with two variables, the time that's passing, the minutes that are passing, and the gallons of water that are filling up in the pool, we have to kind of first determine which one is going to represent the domain and which one will be the range. So for the domain, we will assign the minutes to to be the domain, and I can kind of explain why when I draw the graph. You generally choose the variable that goes at a steady, or like a steady interval, like time goes at, or like time, minutes, days, that kind of thing, that goes in like intervals of 1. So like 0 minutes to 1 minute to 2 minutes to 3 minutes. If you're doing your intervals by ones, then that would be a good one to choose as your domain. So for this, I'm gonna say my domain or my x values is going to be the minutes that pass. And then the range would be how much it's filling up, the gallons. So this would be your range, and this would be your domain. So a reasonable domain, now since I don't actually have a graph here, although they will show us the graph in a second, but I don't have a graph yet, so all I can do is kind of logically decide that my domain would be however many minutes it could possibly take as it's filling up. Can I have a negative number of minutes? No. So a starting point would be 0. 0 minutes to whatever time it ends up taking to fill the pool. Now, are we writing an inequality for that? Not quite yet, because we don't have that final number yet. We could figure it out, but we're not quite yet. We're just kind of like brainstorming the domain. The domain will have to be anywhere from 0 minutes to however long it took until the pool was full. Does that make sense? Okay, the reasonable range would be 0 gallons, because we can't have, that was weird? Because, I think it might have been the computer, was weird. 0 gallons, we can't have a negative number of gallons, right? You can have 0 gallons of water in the pool. We can have 0 gallons, but we can't have negative 5 gallons of water, right? So we have to start at 0, and then it's going to go how far?
Up.
1,000.
What? 10,000.
10,000.
10,000. So there is a certain stopping point for that. So the range will be from 0 to 10,000 gallons. That's just kind of brainstorming our domain and our range. Then we'll kind of map it out. Over here, totally different scenario. We have a restaurant that needs to order chairs for their tables. 1 table can accommodate 4 chairs. So if I have 2 tables, how many chairs will I need?
8.
8. If I have 3 tables, how many chairs will I need?
12.
12, good. If I have 4 tables, how many chairs will I need?
16.
16, good. Keep that in mind.
That's you.
Now again, I'm going to decide that my domain is going to be the one where I can count intervals of 1, which would that be my tables or my chairs?
Tables. Chairs.
Which one?
Table.
Which one can I count in intervals of 1?
Oh,
Tables.
Tables.
That was a very nice one. Thank you.
And then my range or my y value will be chairs. So a domain would be from 1 table to however many tables they need. Sounds way too broad, right? It's like, well, then what's the answer? That's the answer for now. We're just deciding what the domain could be. Can you have a negative number of tables?
No.
No. 0 tables?
Yeah.
Technically, yes, but it says it needs to order chairs for its tables. So that is implying that they have at least a table, right? Maybe even 2 tables because it says tables, right? Okay, so 1 table to however many tables they actually end up needing. The range is multiples of 4. From 4 to whatever 4 times the number of tables. that they use. Just hold on a second, we're almost done. So the chairs are gonna start, if I start with one table, how many chairs am I starting with? 4. So it's gonna be from 4, that's my starting point of my range, to however many chairs I need, depending on the tables that I have, right? But we do know that one of the constraints is going to be, it has to be multiples of 4.
Yeah.
So my range could be 4, 8, 12, 16, all the way to 400 maybe, I don't know how many tables, right?
Who has that thing
I don't know, it could be like a super big giant restaurant.
Bill Cox.
Okay. Okay, now, these are the graphs drawn out. So just like I said, we're comparing the time with the pool, right? We're comparing the time in minutes to how much the pool is actually getting filled up. So it's at a rate of 10 gallons per minute. So at 1 minute, it's going to be, oh, that's 100 minutes. At 1 minute, it's gonna be 10 gallons. At 2 minutes, it's going to be 20 gallons. 3 minutes, and then it's just, this is doing it in increments of 100 minutes. So we see a continuous, think of a pool getting filled up. The hose doesn't stop and then start and then stop and then start, right? The pool is continuously getting filled up by the stream of water. So we call this a continuous domain. Continuous. Squeaky. And I write it in cursive to imply that it's continuous. That's just my little trick.
Oh yeah, because like when you're writing cursive, you don't like lift your pen.
Exactly. So I just continue. That's my little trick. That's a continuous domain. Now, this domain, the domain of a function is discrete if it does not include all the real numbers in an interval. So, I'm jumping from 0 tables to 1 table, to 2 tables, to 3 tables. Can I have 2.5 tables? No. So this domain is going to jump from interval to interval, and it's not going to be a continuous line. It's simply going to be kind of like a hopscotch pattern. And we call this discrete.
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 Oh yeah. Oh yeah. On each dot's gotta get on.
I really wish. Exclamation point.
There you go. Another
Discrete, okay? So if it's a continuous line, it's continuous. If it hops, it's discrete because it's not including the values in between the intervals. Please don't pack up until I tell you. Are you guys with me on what we've done so far?
Yes.
There is a third example. You guys have the ability to open Canvas and look at the example on your own tonight and attempt all of the homework problems. It's okay if you don't understand them. Do your very, very best. You get several tries. Godspeed.
Sorry, at the beginning of the